Hi everyone! So in this second video for our falling mass rotating pulley lab today, I now want to talk about measuring a couple of the other things we're going to need to know to do our data analysis. Now that we've measured the masses, measured the angular acceleration for a whole bunch of different masses. So as you know from having talked about the no-slip constraint, in order to relate the angular acceleration of the pulley to the linear acceleration of the block, we need to know the radius of the pulley. In order to get a sense of, get an estimate of the moment of inertia or rotational inertia of our pulley, we'll also need to know its mass. Finally, I want to get a handle on what some of these hanging masses are. They're all rated in the sense that they all have a stamp on them saying what they are, but I don't have a great sense of how accurate those are, and it won't hurt to check with the balance. Now, for the measuring tools we have for this, so right behind me here, we've got we've got the balance that we've used before. For measuring the pulley, I also have a set of calipers. Now, I wasn't sure about this, but it turns out I can. I was able to take the pulley apart, and where did I put it? I'll be right back. So again, I'm not sure how well you can see this, but I was actually able to take our pulley apart. I'm holding the yoke. So the pulley with the yoke and the wheel itself unscrews really easily from sort of the shaft that it was on. So that's just unscrewing. So what's interesting is the pulley itself. So the actual wheel, it looks like it's made out of some kind of plastic. So it's got the 3 holes, and then it's got sort of this central this shaft that it rides on. Now with the yoke here, how I got that out, you can maybe kind of see. Right, I don't know what you can see. I don't know what you can see, but you can maybe see how you can see how like you could maybe imagine getting a flathead screwdriver in there. Let me actually do that. You can stick a flathead screwdriver in here, and so like I'm driving this back in now. But I was able to I pulled this thing out they're the same on both sides. If you look in here carefully, you can, I don't know what you can see, but maybe you can see that there are little ball bearings around the middle there, and that's what the shaft of the axle of the pulley rides on. So anyway, I was just fiddling with this last night, and I was able to, I sort of figured I would see what I could do with a screwdriver, and it came apart. So that's convenient because now I can just measure the wheel, which is what we care about. I'll measure its radius and its mass. Now, one thing with the wheel that's a little bit interesting is if you look carefully, right, there's a groove in the wheel. And then, right, it needs to have a groove because that's where the string sits when I wind the string up. And what I edited out of the measurement video was in between the video is only about 5 minutes long, but that's because I edited out all of me fumbling with a string, probably for a good 5 minutes for every run, just trying to rewind the pulley and step off the chair and all that while not dropping it. It took a couple of tries, but so we're gonna have to measure. I'll try to measure both of these things, and I'll draw on the board exactly what I'm measuring. So here we have a set of digital calipers. I don't know what you can see, but right there are these jaws that sort of open, and then you can read the display here. These read to 0.01 millimeters. There's also the sort of depth measure here, so you can sort of use the bottom of this with the tip as a sort of a depth probe. So we'll do both. So our pulley, right, so it's got this outer diameter, right, and so I'm going to draw that here, and then sort of where the groove is, right, so what I'm trying to draw with this dashed line is sort of where the groove goes. Let's start by first measuring the outer diameter. So I'm going to crank this open and sort of come in here, something like this. And so technically, calipers of this sort are not really the right tool to use to measure round objects. You should really use what's called a micrometer that has flatter faces. So I'm just sort of fiddling with this, and I'm getting sort of a range here, a little bit of a range as I try to set the jaws around this. And depending on how I sort of slide this thing around. So this reads to 2 decimal places, but I would say from having fiddled with this, I would call this outer diameter I would not be confident in saying sort of anything better than 50.2 plus or minus 0.1 millimeters. For the outer diameter, so I'll call that OD, of my pulley, just because of trying to locate exactly where the diameter is. So here's the other bit, right? So let's think about the depth part of this. I'm going to see if I can sort of stick this depth gauge into the groove here. And if I sort of do that, that's a little sort of come at it fresh. Okay. So for the depth, I got 0.94 millimeters. So let me label that. So that's my groove depth. So measuring from the outer diameter inwards to where the groove bottom is. .94. Let's give this a couple of, just from having done this, let me do this one more time. Set the gauge in here. So I can the gauge isn't really in. Okay. Oh, and I'm noticing that this thing does not actually, this depth gauge does not go all the way into the bottom of the groove, because the groove is actually V-shaped. So that measurement is definitely systematically wrong. And the groove is also too narrow for me to actually I can't just like go in. I can't. The groove is too narrow for me to get the jaws here in all the way. So let's see what. Yeah, I can't really. Maybe. Okay, well maybe I can. Maybe I can because that depth measurement was definitely wrong. But or no, that's no. I'm definitely not getting the teeth in. Yeah, I'm definitely not getting the teeth in either. If I were to try to, I'm gonna try to. Yeah, no, I'm not getting. I'm not getting the groove depth very accurately at all here. Let's see what I can do with a ruler. If I were to estimate the depth of the grooves with a ruler, I would have to sort of give this an estimate. It's about 2 millimeters. So let's just so 2 plus or minus 2. Let's just say that there's a half, with a sort of a ½ millimeter uncertainty. Yep. So there's of course the question of what value of R to use, right? So the string is wrapped like in the inner groove, right? But then because we've got like nearly 1.5 meters worth of string, right? The string starts to pile up in the groove. So the actual sort of effective radius of my pulley is going to just change slightly. It's probably going to be somewhere in between sort of what, it's going to be sort of less than, it's going to be more than the sort of inner diameter here, but it's going to be less than the outer diameter. So there'll be a fairly large uncertainty actually in what the actual radius of the pulley is, and that's something you're going to want to take into account. Fortunately, the pulley mass is a little bit easier to measure, so I've got that here. I'm just going to stick that on. And that one's easy, so this is 7.6 grams. And let's just say plus or minus 0.1 gram, because that's sort of where this can read to. And finally, let's measure some of the masses that we're dealing with. So I've got my mass hanger here. I'm going to take the string off. There we have, righto. This is the, I'm not good. Okay, there we are. So this plastic hanger was nominally 5 grams. Let's see what it actually is. Oh, it's actually 5.1. So M hanger 5.1 grams. So for the other ones that I looked at, I got 30 grams, our lowest mass, by taking 5, and then I took the 5 gram hanger, and then I had a 20 gram mass and a little 5 gram mass. So let's just check the 5 gram mass. So that's actually 5.0 grams. So that's good. Let's just check the, so I have 2 of these 20 gram masses, so let's just check one of them. Nope, that one's a little under. (19.8 grams). I have another one as well. Let me see what that ends up being. No, that's even more under, so that's 19.4. Okay. Okay, let's see what else. So okay, so I got 30, but I got 30 grams by taking the 5 gram mass, adding a 20 gram and then a little 5 gram. I got 35 by having 5 plus 20 plus 10. Let's check that 10 out. Where is my, here's my 10 gram mass. That's 10.1 grams. Right, 10 gram, 10 G, that's 10.1 grams. So I got 40 grams by combining 5 from here, a 20, a 10, and my 5. So I've measured all of those. 50 I got with 5, 20, 20, and 5. 60 I got with my 5 grams, a 50 gram mass, and another 5 grams. So let's just put the 50 gram here. That's 50 grams. Okay. And let's see. So that's 60. 80 grams I got with 5, 50, and 5, which is 60, plus 20 makes 80, and I've measured all of those. And then the only thing I haven't measured is I had 100 gram as well, so I got 120 grams total by combining 5, 100, 10, and 5, and 180 by 5, 100, 50, 20, and 5, and these are all things that I wrote down in my lab notebook. If you were doing this experiment live, you should write this in your notebook as well. The only thing I haven't measured is my 100 gram mass, so let's see what that is. Alright, 100.1. Okay. So I think you can see sort of a range of the measurements. There's some, there's a, and you can try to sort of estimate an uncertainty in the mass based on this, right? It's going to be, a few tenths of a gram most likely, looking at these sort of various combinations that I used. But yeah, so that gives us a sense of the uncertainty in the mass. We've now measured the pulley radius and the mass. I think you have all the data that you need to analyze our work. So for the rest of today and for next week, carry on with doing the data analysis and writing that you'll need to do for your final report.